we're going to be talking about protein synthesis. Okay, there's two steps to protein synthesis. You have transcription and you have translation. So the first phase, transcription, is transcribing the message in DNA onto your messenger RNA molecule. The reason why that's important is because DNA cannot leave the nucleus. Therefore, there has to be a messenger taking the information encoded in DNA to the cytoplasm where ribosomes are located. Okay, so the first step in transcription is to separate your DNA strands. Okay, so you have two strands of DNA. RNA polymerase does the job of separating the strands of DNA. RNA polymerase also does the job of matching nucleotides, RNA nucleotides, to your template strand of DNA. So the template strand is the strand that runs 3 to 5. We're going to make messenger RNA in the 5 to 3' direction, so anti-parallel. And so as RNA polymerase unzips your DNA, what happens is nucleotides are going to be paired up by the RNA polymerase. So T's will pair with,
Yes.
A's will pair with,
Use.
okay, C's will pair with,
Use.
so on and so forth, okay? So as RNA polymerase continues unzipping your DNA strands, okay, nucleotides are going to be paired up with the template strand of DNA. Okay, once RNA polymerase reaches the end, we get to termination or the stopping sequence, signaling that transcription is complete. And what ends up happening is that the DNA rezips or zips back together, the hydrogen bonds are formed, DNA stays inside of the nucleus, and we will have a messenger RNA molecule like this. Okay, so this is our messenger RNA. The first version of the messenger RNA is called the primary transcript. There has to be some modifications done to the messenger RNA. So what I can't show you, but what I will describe is you have your 5' cap. Okay, what do we put on this end? Poly A tail, and then what do we do in the middle? We have to remove the introns. Right, okay, so we remove the introns, and then what we would have is our mature messenger RNA that is ready to leave the nucleus, go to the cytoplasm, and then be translated into a protein. Okay? So translation is carried out by a ribosome. Okay? So ribosomes are kind of like your construction workers that build your protein using the information encoded on your messenger RNA. So a ribosome will attach to the 5' end of your messenger RNA, and an initiator tRNA, which has a complementary anticodon, will bind to the start codon, okay? And on your desk, you have a codon wheel. Who can tell me which amino acid goes with this AUG start codon in messenger RNA? Okay, methionine. So an initiator transfer RNA carrying the amino acid methionine is going to come in and bind to the codon, which is a triplet code for the amino acid, okay? So on your messenger RNA, you have codons, which code for the amino acid, but the tRNA or the transfer RNA is the mechanism or the carrier of the amino acid. So once we have the initiator tRNA sitting in the P site, we have the A site that is open and available. The next amino acid is going to be brought in through the A site, okay? So as the process proceeds, we have the ribosome walking down the messenger RNA or translocating, and each codon is read, and after each codon is read, a transfer RNA brings in the matching amino acid. Okay, so we have this AUC as our codon. What will be our amino acid? Isoleucine. How does isoleucine get there? We need a tRNA with what anticodon? this is UAG. This is isoleucine. Wonderful, thank you. Okay, so then your messenger RNA, the next codon says CAG. What happens here is, once the next tRNA brings the next amino acid, there has to be a peptide bond formed. So a peptide bond is going to form between the tRNA, or between the amino acids, and that is a type of covalent bond. I cannot get my bonds to stick together. Okay, so we have our messenger RNA with the codons, we have the tRNA with the anticodons, we have our amino acids that match the codon. Okay, so we have a peptide bond forming between the amino acids. Once this tRNA has brought its amino acid, peptide bond has linked them together, this will move this into the P site. So the growing polypeptide chain is going to be moved to the P site. The transfer RNA that brought the first amino acid, it goes out through the E site, or the exit site. And then now we have our A site sitting over the next codon, okay, ready to add the next amino acid, okay? So once we have this amino acid, or this codon sitting in the A site, now we need which transfer RNA, or transfer RNA with which codon bringing in the next amino acid? G, UC, and what's that amino acid that it should bring? Valine, okay? So valine is gonna come in to the A site, like so. A peptide bond is going to form between valine and isoleucine, linking them, and then this amino acid in the A site is going to move into the P site. This amino acid, that tRNA holding the valine is going to move into the A site, or P site, excuse me. This one goes out the E site, and then what we have is the A site open to add the next amino acid, okay? So the ribosome will continue that process. This is called elongation. We're elongating our amino acid sequence. So then when we get to the next amino acid, the next messenger RNA, okay, we're going to add the next amino acid, okay? tRNA is going to read what? CAU, bringing in what amino acid? What are we looking at? Are we looking at the anticodon or the codon for the amino acid? We're looking at the codon to determine the amino acid. So therefore our amino acid needs to be what? Valine. CAU is the anticodon that is complementary to the codon. Did we mess that up?
Yeah.
How? Did I mess that up?
No, it was us. We said the wrong amino acid.
Okay. It's okay. We'll just switch these up. That's glycine. And this one should be valine brought in. Okay? And so then we link our amino acid in a peptide bond. Okay? Like this. So what we end up with is eventually a chain of amino acids. Okay. All right. Then this moves into this goes out the E site. It's done. Okay. This is going to move into the P site, and now that A site has the stop codon. Okay. So what happens at this point is that a release factor is going to be added that causes water to be added to the amino acid sitting in the P site, and then what we get is everything detaches. You're going to have a chain of amino acids, or polypeptide. So everything else goes away to be used later to make a new protein. We're going to put it up here. This is our polypeptide or amino acid chain. Okay? This is the primary sequence of a protein. So we have our primary sequence, which is the chain of amino acids linked by peptide bonds. Then we have to have the secondary structure, folding, alpha helixes and beta pleats. Tertiary structure, additional folding with disulfide bridges. And then we have sometimes quaternary structure. So where proteins fold is inside of a structure called the chaperonin. So your polypeptide chain goes in as a linear sequence of amino acids. Okay, you have your chaperonin providing a safe environment for it to fold, and then what comes out is a protein folded into your 3D structure. And at that point, you have a functional protein. It could be hemoglobin, it could be insulin, it could be any number of different proteins that our bodies need to function properly. Everybody got it? Mm-hmm. Okay. So at your desk, you have some pieces that you're going to be using to replicate the process that I just did on the board. So you have a DNA strand. You have a number at the top of your DNA strand. You're going to take the DNA strand that has pre-printed nucleotides, and you're going to use the blank piece or the blank strand to make the complementary DNA strand. So that's step one. So what you've done is now made, or you will be making, 2 strands of DNA. So that means that we're not going to have what letters on our DNA? No U's, right? Because in DNA we have A's with and G's with C's. Okay. Second step, once you make your complementary DNA, you're going to use the mint green piece to make a messenger RNA using the template strand of DNA. So which one is the template strand? The one that goes what direction? 3 to 5. So we use the template strand 3 to 5 to make our messenger RNA, which is complementary to the DNA strand. So guide your messenger RNA strand along so that the bases pair up the way that they're supposed to. Once you make your messenger RNA, or you have transcribed your DNA into your messenger RNA, you're now going to translate your messenger RNA into a sequence of amino acids. And you have transfer RNAs to help you do that. And you have a little yellow piece to help you represent your amino acids. So I like what you have on your desk. I'm seeing some good polypeptide chains. All right, so who has a number 1? Number 1 at the top of your card. Who has a number 1? Okay. Okay.
My stop is at number 4.
So you have a mutation.
Yeah.
So go back and check your sequence. And make sure you transcribed and translated correctly. Did you find your error?
Yes, you say it's supposed to be like a 3-5.
Okay. Yes.
So actually, there's a question.
This is like 3-5.
Right.
So this is
So which one do we
Big piece of
use
this.
to make your messenger
Oh,
RNA?
shoot.
So if we have to build messenger RNA in the 5 to 3' direction, then that means that we have to use this one to make the messenger RNA.
Oh, so it's like it's really just
Yes.
So this is just the,
This is the second strand of DNA.
okay.
All right. So remember, we build messenger RNA in the 5 to 3' direction. So that means that we have to use the DNA strand that goes 3 to 5 to make the complementary messenger. Yes. Start from the center. Okay, so why are you looking for T's? Because are we using DNA to make our amino acid sequence, or are we using the messenger RNA? Right. So we have to have our messenger RNA from DNA, and then messenger RNA will be used to make our. Yes. Okay. So this is your strand that you're going to be using, and you're going to take this strand, this one, to make this. Okay, and then once you make this, using your template strand, then you will translate it into an amino acid sequence. Yes. So this would be your 3 to 5. That's your 5 to 3. So then this can be translated. Yes. So we have our template strand, we have our coding strand, and then we have a template strand, which is going to be used to make messenger. So that should be you, right. Okay, right. So then you take this to make this. Okay. How about you? Oh, okay. So we take A. That should be U, G, G, C, G, C. Right. Okay. Right. It repeated. Right. Okay. All right. So who needs help?
Is there a software?
No.
Okay. Never mind then.
Let's check your work. We're only going to look at your amino acid sequence, and that will tell you if everything else is done correctly. So if you have sequence number 1, your amino acid sequence should be this sequence here. Yes? Okay. If you have sequence number 2, or strand number 2, your sequence amino acid should be this. If you're not getting these amino acids, that means somewhere in either your transcription or translation process, you have an error. So let's go back and check that. And then if you have strand number 3, your sequence of amino acids should be this, okay? All right.